Here, man has locked his heaviest artillery against premature death: antibiotics. Thousands of lives were saved in war thanks to this killer of bacteria. Thousands of men spared crippling amputations. Wartime necessities speeded up research and production of antibiotics, and all of mankind benefited from it. This child, infected with impetigo, only a short time ago would have had to suffer for weeks, for medical science was almost powerless against the bacteria which cause skin infections of this sort. Now she will be healed in a few days, thanks to the help from man's most successful micro-killers. What are these miraculous substances that kill bacteria?
We call them antibiotics. In Greek, anti means against. Bios stands for life. Antibiosis means that one living organism kills another. The term is not new. Observing nature, man has long known that each species must fight for its survival. The fittest survives and keeps the species strong and healthy. This natural antagonism keeps balance among the living creatures in nature. This is also true for the invisible world of microorganisms. The microscope reveals how one single-cell animal feeds on another. This is what antibiosis means. But feeding or killing the opponent is only one way in which antagonism is expressed. There are other chemical substances that will prevent other microorganisms from crowding them. This is their way of expressing antibiosis. Well, now that we know what antibiosis means, we may be able to answer what antibiotics are. Antibiotics are chemical substances produced by microbes, which tend to inhibit the growth of other microorganisms and even kill them. In other words, antibiotics are not man-made drugs, but chemical substances produced by microorganisms.
Let's investigate this more closely in a biology laboratory.
This small dish will help to demonstrate the action of antibiotics. This dish is filled with a jelly, on the surface of which we grow a thin film of bacteria. These round bacteria are called staphylococci. These bacteria would multiply in the human body just as they multiply in the laboratory culture media. An English physician, Dr. Alexander Fleming, interested in bacteriology, worked with a similar culture of staphylococci, but inadvertently, a speck of dust fell into the dish, carrying a mold belonging to the family of molds called penicillium. We have put such a mold into this dish ourselves. While impurities often spoil the pure lab cultures and are thrown away, in this case, Dr. Alexander Fleming decided to investigate their action. Several days later, he noticed what we're seeing now, namely that clusters of bacteria had spread all across the dish, but left a ring of clear jelly around the penicillium mold. Evidently, the mold was doing something to the staphylococci that prevented them from spreading into this area. Dr. Fleming tried dish after dish of the same bacterial culture, always with the same result. The penicillium mold fought off the bacteria. Dr. Fleming described his observations in a paper that at the time failed to stir the scientific world. In 1938, after the success of sulfa drugs had rekindled an interest in healing with chemicals, a group of Oxford scientists under Dr. Florey picked up Fleming's experiment. From Fleming's observations and from Florey's research team, and from the work that followed in England and America, a new science was born. Science of antibiotics. A new name was added to our vocabulary, penicillin. The name derived from the mold that stopped Fleming's staphylococci, and which belongs to the family of molds, penicillium. Physicians all over the world use penicillin today.
That's very good. Your temperature's dropping.
Fine.
For this type of blood poisoning, penicillin is a sure weapon. You won't need to worry. We'll have her out of here in a week.
Yes, doctors use penicillin with great success because they have a potent killer of disease-causing bacteria, which will not endanger the cells of the human organism. Here is why this is so important. Processes by which an organism lives, our own organism or that of a microbe, are pretty much the same. Therefore, whatever would interfere with the chemistry of the microbe would in most cases also harm the human tissue. The problem is to find antibiotics that kill harmful bacteria but do not hurt the patient. Penicillin is such an antibiotic, harmless to the human and effective against many disease-causing bacteria, but not against all of them. New antibiotics are being developed, each of them interfering in some way or another with the life cycle of some harmful microorganism. In measles, for instance.
It's measles, all right.
Certainly looks like it.
If you'll give her this antibiotic 5 times a day, I think that will take care of the measles and those after effects that we worry about as well.
Well, that's fine. Thank you very much, Doctor.
I'll see you later, Kathy.
Yes, antibiotics fight against many kinds of bacteria, each affecting some microorganisms in some special way. For instance, one group of antibiotics interferes with the ability of the microorganism to use up food to produce energy. While there is food in abundance all around the microorganism, its ability to use up the food is impaired. As a consequence, the microbe dies of starvation. Another group of antibiotics acts upon the thin membrane, which envelops the cell and dissolves it. The microorganism practically falls apart under the attack. Penicillin belongs to a third group of antibiotics, which probably interferes with the ability of the cell to reproduce. Bacteria and other simple microorganisms reproduce by dividing. A mature cell produces two identical cells by division. These cells mature and divide again, thus multiplying the species. In the presence of penicillin, cells of bacterial microorganisms grow to maturity, then continue to grow, but fail to divide. Eventually, the cells outgrow their own ability to live, and they die. With these miracle drugs obtained from mold, man has made giant strides toward a total victory over harmful bacteria. And because many molds have their origin in the soil, a new research specialist came into prominence, the soil specialist known as the mycologist. Mycologists develop strains of pure mold, yeast, actinomycetes, and hosts of other microorganisms. They guide them through their short life cycle and try to influence their life habits in such a way that they produce chemicals which can be utilized for the benefit of man. Thousands of mold cultures like these are studied in research centers. Once the right kind of microorganism has been found, it is isolated. Pure strains are reproduced. Next, the pure culture goes to the fermentation chemists. They multiply the microorganisms by the hundreds of millions by providing them with a place to spread and with the best food. This ensures rapid growth and encourages them to produce the desired antibiotic. Then other specialists take over until the pure drug is obtained. Antibiotics, the miracle drugs of our time. Thus, antibiotics produced by living microorganisms help mankind in the fight against disease. Antibiotics give the doctor the heavy artillery to fight and conquer pneumonia, to fight successfully deadly meningitis, to attack various streptococcus infections. But all the heavy artillery against the onslaught of disease has not yet been produced. This hospital and many others are still filled with the sick for whom we have no antibiotic cure. Therefore, research cannot stop. The era of antibiotics has just begun. Every day we are coming closer to a time when we will understand more clearly what goes on inside the minute chemical workshops of the cell. Every day we are widening the horizons of knowledge in the quest for a better, healthier, and happier future of mankind.